Today I'm going to talk about, do a little tutorial on alkalinity. High alkalinity, how to lower it. Low alkalinity, how to raise it. And we'll use this pool here as an example. So we're going to assume again that this pool is 5.5 average depth. That would give us a 3.5 shallow end and an 8-foot deep end. Now again, using Google Maps, I have a video on this, Google Maps for gallons. Right click it, come down and measure distance, and then just click around the pool. And what's another awesome thing about Google Maps? And we're not going to do the steps because there's not going to be a whole lot of gallons right there anyways, so I'm going to worry about that. Now we got 622 total area. Now you come in here at 622 total area times our average depth of 5.5 times 7.48, which is how many gallons that are in a cubic foot of water. So that gives us 25,000 gallons. We're not going to worry about that 589 either because we're just going to round it off. You don't want to really go up on that and round it off to say 26,000 because you'll put too many chemicals in there. And so it's always best to go down, not up. So we're going to go 25,000 gallons. So we'll take the 25,000 gallons and we're going to divide that by 10,000, and that gives us a 2.5. Now on here, as you can see here, you got sodium bicarb, raises it 2.24 ounces for 1 ppm in a 10,000 gallon pool. Muriatic acid is 2.56. Will lower it 1 ppm in a 10,000 gallon pool. So those are the numbers I'm going to be using right there. So if we have that pool right there, which was 25,000 gallons at 2.5, we have an alkalinity of say 60, and we want to raise that up to say 100, 110. Let's just go 100 to make it easy here. So that gives us 40 that we want to bring that up. So we got to multiply that by 40 is how much we want to bring it up. Multiply that again by the 2.24 ounces for 1 ppm, and that gives us 224 ounces of sodium bicarb. And we'll divide that by 16 ounces in a pound. We need 14 pounds of sodium bicarb to get that pool up to 100. And don't worry about it raising the pH a little bit because it's not going to really affect the pH a whole lot. But it will bring it up a little bit, so don't worry about that. You can worry about that after you get that alkalinity to the way it should be. Now on the flip side of that, if we have 25,000 gallons and we got 140 alkalinity and we want to bring that down by 40, now we're going to multiply that by 40 and multiply that by our 2.5, let's see, 2.56 muriatic acid, and that's going to give us 256 ounces. Now we're going to have to divide that by 128 ounces to a gallon. That's going to give us 2 gallons of acid that we're going to need in that pool to get that alkalinity down. Now you don't want to dump 2 gallons of acid in that pool all at once. That's not a good thing. At most, since this pool doesn't have a spa, at most I would probably do like maybe 60. If you can come back 2 times a day, that would be totally awesome, but that's not going to happen either. At least once a day. You have to come back to this pool at least once a day to get that down. So I would dump in probably maybe 60 ounces or so, and start off with there. Maybe a little bit more, maybe like 3/4 of the gallon. Dump it in several different areas. Dump in a little on this side of the deep end. Take your pole, move it around. Just don't let it calm down to the bottom, because when it gets down to the bottom, it's going to be a pH of 3. Excuse me. You don't want that. So you want to move it around with the pole. Stir it around with the pole really good and get that acid into the water. And come over here, dump a little bit there, move it around, get it in, stir it into the water, and put a little bit right there too. Move it around. Just don't all do it on one spot. Move it around the pool. Sodium bicarb, make sure the pool is running and dump that into the skimmer. Slowly into the skimmer. You just don't want to dump all at once. Just do a little bit at a time. And it's not very good to mix chemicals either. Certain chemicals don't go well together. So if you're going to do that much sodium bicarb, excuse me, sodium bicarb, do it just that. Don't add anything else to this pool. Just work on that. So, and that's because another thing about an alkalinity. When you come into this pool and take over this pool and you know nothing about this pool, and you come into this pool and you got an alkalinity reading of 180, don't automatically assume you got to bring that down to 100, 110 reading alkalinity, because this pool could be high in conditioner, especially if you see a tab floater in there. Assume that it's going to be high. So run a conditioner check on it before you lower that alkalinity. And the reason being is, if you're on 180 alkalinity, and this pool, say, has a conditioner of like 250. So you subtract your 180 alkalinity, your reading alkalinity, subtract from your conditioner, because conditioner adds to the alkalinity because it's a pH buffer, and it also helps buffer the alkalinity. And so you have to add that, and also goes to balancing the water. So you have to subtract that conditioner out of there. And yeah, I'm touching the screen here. Anyways, so what then you do is you have that, and then you multiply by your fraction of your pH. Say a pH of 7.9 and 8.0 is a 0.36. So that gives us a 90 alkalinity. So that's why you don't want to touch that. You really need to check that conditioner first. Because if you were to bring that down with that 250 conditioner, let's say you're going to bring that down to 90, subtract your 250 conditioner, and then multiply your 0.36 on your pH. Now you're at a 0 alkalinity. And that's extremely acidic. And then you start to have problems with that pool, you know, etching it and really messing that pool up, and if you leave it like that. So that's one thing to really be aware of when you run into a situation like that, is that check that conditioner, because let me just show you real quick here what your fractions of factors are in the pH. That'll be the factors of the pH when you balance water. 7.9, 8.0, the 3.6, and then so on. You can go ahead and write this down. But always subtract your alkalinity from your conditioner and then multiply it by the fraction right here, and that'll give you the true alkalinity of that pool. So you want a true alkalinity of around 80 to 100. There is pretty good. 80 is pretty good. It'll help keep your pH down a little bit. It won't help that pH rise. It's supposed to kind of like keep it more stabilized when you have an 80 alkalinity. But who knows? Yeah, every pool is different, you know. I mean, if you got spas in here, if you got a spa in there, you got waterfalls and all that stuff, and that pH is going to be high no matter what. So don't stress on that. But if you like the video, please comment. Again, please share. Subscribe, and please leave comments. Like I said, it's probably my 4th video here, and I'm kind of like maybe going on a little bit here, but trying to give the best info that I can on these videos, so you guys can start doing these pools the right way, instead of all these corrosive pools, these etched pools, scaled out pools, and things like that. But so please, if you have any comments, leave them down below, and I'll be sure to get to them. All right? Thanks. Bye.